Hey guys, welcome to the second lesson on fundamentals of C# programming. Today we're going to be talking about how we make decisions in C#. We're going to cover how we use the if statement and nested if statements. We'll talk about how we use compound expressions with if statements. We'll talk about how we use switch statements, and then we'll finish by building a simple application that we use the stuff that we learned. Alright, so let's get started. So when we want to check for certain conditions and do actions based off of those conditions and change up the flow of how the program is read, we use one way we can use if statements. So an if statement is a statement that takes in an expression and evaluates that expression. And depending if that expression evaluates to true or false, it will do different actions. So the basic syntax of an if statement is if, and then in parentheses, that's your expression that's going to be evaluated. And the expression that's being evaluated has to either evaluate to a true or a false, always. If statements only understand true and false values. So let's say, for instance, we had an integer called x and said it's equal to 5. If we made an if statement that checks to make sure if that x is 5, we can say if in parentheses x equals with the 2 equal sign. That means we're doing a comparison and that returns either true or false. So we can say if x is equal to 5 in parentheses, then we'll do something. So the first thing to note about an if statement is, by default, if we don't put in what are called blocks, which I'll explain in a second, if we don't put in blocks and just go to the next line and type our code here, like for instance, let's say we did console.writeLine, x is 5. If we wrote that like this by default, the if statement, the line after the if statement declaration is the only statement that is included in the if statement if you don't put in blocks. So if we don't put in blocks, this is the only line, only one line after the if statement will be included in that if statement. But this would work how it is now. So let me run the program, and you'll see that it says x is 5. But if I were to change x to 6 and then rerun it, now 6 is not equal to 5, and then I run it, now we'll see that it doesn't say anything. So the if statement is working. However, it's a good programming practice to get used to of using blocks. So I'm just going to show you what that is, and then I'll show you the differences with using it and not using it. So blocks are curly braces. As you can see, we have a set of blocks here, a set of blocks here, and a set of blocks here. The open and closing curly braces. And what they do is, if you have code within those curly braces, you're saying combine these all together as pretty much one statement is what you're saying. So that it executes that code together, and it's saying include these all together. So if I put these blocks in around my if statement, so I'm saying if x equals 5, and then I'm putting blocks. Now if I put multiple statements, I'll put this a couple times. If I put it 3 times, it will run, because we're saying if x is equal to 5, if that's true, do all the statements within the curly braces of the first if statement. So if I run this, we're not going to see anything actually, because I have it set, x is 6. But if I change x to 5 and run it now, we'll see that I see that the 3 times. If I take out the curly braces, I'll just put this over, and now run it, we still see all 3, but that's because, actually, let me first change it. Let me change this to 6 and now run it. Now you can see why that's happening. Let me run it now. Notice how we only see 2 now. And we only see 2 because the first statement is included into the if statement. So because 6 is not equal to 5, this evaluates to false. The if statement evaluates to false. So this line does not get run because that line is a part of this if statement. But because we're not using blocks, these two other statements are kind of floating in air. They're not a part of the if statement. So these two lines will always get executed no matter what. So that's the difference between using in if, using blocks and not using blocks. So let's just do another example of this without using blocks so you can see how it works. So let's say I had int number equals 5. And I said if number is greater than 6, console.writeLine, let's just display an A. And then the next line, let's just display a B also. Now, if we run this program, you can see it says a B. It says a B because it first checks, okay, is 5 greater than 6? No, it's not. So the if statement evaluates to false. Because there's no blocks, the first statement following the if statement is the only statement that's included in that if statement. So the A is a part of this if statement. So it says this is false, so that it does not execute this A. But then it keeps on going and then executes the B because the B is not part of any if statement. And then so B will always get executed. You can see though by default in Visual Studio and Visual Express, if you're using that, if you don't supply block statements, it automatically indents the statement following the if statement to show you that that statement is a part of that if statement. If I don't put any blocks in, and then the second console.writeLine gets unindented to show you that it's not part of the if statement. But if I forced this and indented it or whatever, lined it up the best I could like this, it doesn't mean that now it's a part of the if statement. If I still ran it, it would still only say B because it still knows. But so the indentation is just there to help you by default, but it's not actually do anything with the if statement. So, but now if I go ahead and put my blocks back in and run this, now nothing will display because now they're both included in the if statement. And if I change this to like a 7, now 7 is greater than 6 and run it, now I will see my A and B. Alright, so now, like I said, an if statement can evaluate anything or any expression that evaluates to a true or false value. And anything, so the things that do that are any comparison operators like greater than, less than, equal, not equal, all those that we did in the last lesson, and bools, because bools are true or false values, so they can always be evaluated. So I just want to show you this example. So let's say we had a bool said my bool is equal to true. By default, you can pass in a bool to an if statement without putting any comparison operator in, and that it will check if that is true. So if I say if my bool, just like that, and then my blocks, and then I say console.writeLine, my bool is true, by default, it will check if my bool is true in this statement. So if my bool is true, it will execute this line of code. And which it does, my bool is true. If we want to check if it's false, then we'll have to be like, okay, if my bool equals false. So now if we run it, now we won't see anything because my bool is true. And we're checking if it's false. So that's that. That's with bools a little bit. But now I want to get into with nesting if statements. So nesting if statements is the concept of putting if statements within other if statements to get more precise comparisons and readings and stuff like that. So let's say, for instance, we wanted to make a program that asks the user to enter a number. When they enter the number, we're going to check that if the number is between, let's say, 5 and 10. If it's between 5 and 10, display a message saying it's between 5 and 10. If it's not between 5 and 10, then we won't display anything. So to make this program, let's first make what are called constant variables. A constant variable is a variable that can't change. And in our example right now, this is a good time to make a constant variable because our low and our high that we're going to be checking against should never change. So let's make our low variable. So let's say we have const int low, and we'll say that's equal to 5. So this is what we're going to check against. This is one thing. And then we'll say const int high equals 10. So the const keyword, so this is just a normal variable declaration. If we don't have the const, this is just a normal variable. By adding the const, it means we can't change it. If I try to change it by going low equals 6, for instance, I'm going to get an error because if I highlighted it, whatever, it just says it just means that I can't change a constant value. Okay, so now we have our two constant variables. Now let's make another variable. Actually, we don't have to yet. Let's first ask the user to enter in an integer or enter in a number. So we'll say console.writeLine enter a number. Now that we asked them to enter a number, we need to read in that number, which we did in the last lesson. So to do that, they're most likely going to we're going to assume that they're going to enter in a integer. So we'll make an integer variable that will hold our data. So we'll say int number equals, and then it's the console.readLine. But remember, this is going to error because a console.readLine comes in as a string. So in order for us to set a string equal to an integer, we have to parse it or convert it. So we'll use our parse method. So int.parse, like that. So now our int number variable is holding whatever was typed in, and we're holding it as an integer. Now that we have that as an integer, now we can start doing if statements and doing some checks with it. So the first check we want to do is we want to make sure that the number entered is greater than our low value. So we'll say if number is greater than low, and then our block. So now if number is indeed greater than low, it will go into the if portion of the if statement. So that's here. So that means it will enter into this code. Now we want to do another check. So this is where nesting if statements come into play. We want to check, well, if the first if statement's true, that we want to check is the second one going to be true, and that is if it's less than the highest value. So we'll say if number is less than high, and our blocks again. So if this is true, so if the first if statement is true, it will come in and then check this second if statement. If the second if statement is true, it will come into here and then do code that is inside of them both. And that's why they're nested. If this if statement, the first one, evaluated to a false value, it would have completely skipped over all this and not even looked at it, and then would have continued down here. But because we got into here, now we can display it. So we'll display all our information. We'll say console.writeLine. So if we're at this point of displaying this console.writeLine, that means that our number is greater than our lowest value and our number is less than our highest. So that means our number is between our range that we wanted. So now we'll display our message using placeholders. We'll say first placeholder, which is going to be the number that they entered, is between our lowest value and our highest value. So let's plug in our numbers. So number is what they entered. The second one is low, and then the third one is high. So everything seems to be good. So now let's run the program. It says enter a number. So we'll enter in one that actually works first. So we'll say 7. And then now it says 7 is between 5 and 10, which is correct. If we run it again, and I put in, let's say, 4, nothing will happen. It just says press any key to continue, meaning the program is terminated. Nothing happened because the statements aren't true. So let's go through it with 4. So it says if 4 is greater than low. Well, low is 5. Is 4 greater than 5? No, it's not. So it never even entered into here. It completely skipped over it. Now, I want to show you this method of debugging that allows us to test and see how the computer is running the program. So you don't have to know this. This is just for testing purposes. But I'm going to put in a breakpoint right at this if statement. The breakpoint simply says once the code gets to this line, stop running the program, and then we can step through the program by ourselves and see what's going on. So if I run the program now, it says enter a number. I'll enter one that satisfies the if statements by hitting a 7. Once I hit enter, it comes in showing us that our code is at that point. Now I can step through the code or step into the code to see what kind of what it's doing. So if I step in, this is what the computer is doing. It goes in. Now, since it was true, it got into the second if statement. Now it does this check. If it goes in, if I can highlight. If I highlight the number, it says number is 7, which is true. And if I highlight high, it says number is 10. So 7 less than 10, that's true. And it keeps on going in. And then now we can see that it got to the statement because both of the if statements were true. And then it stops and leaves. So that's the first way. So that's the first thing it does. Now I'm going to run it again, but this time I'm going to put in a 4, so it's not true. I put in a 4. And notice now 4 is stored into number and 5 is stored into low. So 4 is not greater than 5. So when I step through it this time, it completely skips over this if statement. So it doesn't even go in. And that's all I wanted to show you with that. So you can see that the if statements are actually changing the flow of the program. Alright, so now, although this program works how it is, there's a better way to do something similar to this. And the way we can do that is by using what are called if-else statements. If-else statements are just a normal if statement that if the expression is true, it does the first part of the if statement. But the else part says that if that is not true or false, it will do the else part of the statement. So first, before we rewrite this program using the if-else statements, let's first just go over if-else statements. So let's say we had int x equals 5. Let's do a check. If x equals 5, then we'll display the message hello. Now, if we run the program, we'll see that it displays hello properly. Now, we want to make it, let's say, if x is not equal to 5. So let's say if x was 6. We wanted it to display the message goodbye or bye instead. And that's how to do that, we use the else statement. So the else statement goes by just going after the if statement blocks, putting in the else keyword, then hitting enter, and then putting in the else blocks. So by putting in the else blocks, now we're saying if this is not true, so if this does not evaluate to true, do whatever is in the else section. So for the else section, we're just going to say the message bye instead. So let's run it now. You'll see that it still says just hello, and it does not say the bye because that's in the else portion of the if statement. But if I change this to 6, which now makes this false, now it should evaluate the else part. If I run the program, it does say bye. So what's happening is it's saying if x equals 5, so it's saying if 6 equals 5, which it doesn't, so it jumps to the else part. I'll show you this by using the breakpoint again and running the program. So we can see it starts off in there. If I step through it, that evaluates the false, so it goes right to the else and does that. So now that we know the basic of else statement, we can also nest. We can nest with if-else statements. So I mean, it would be the same exact way. Let's add another variable. Let's say we had my bool equals true. Now we could say, okay, if the first if statement is true, we can say, okay, let's do another if statement. Let's say if my bool, I'll put this in, equals true. Then we'll do something, and then we'll do another else. So if my bool is true, we'll display console.writeLine hello. If that's not true, we'll say I don't know. It doesn't really matter. Console.writeLine hello world, and then if this whole if statement is not true, it will still do the else part of the if statement and do the good in the by. If this is true, so if x equals 5, it will come into here, which is another which is a nested if statement with an else attached to it. So it'll come into here, and then it will say if my bool equals true. If it's true, it will display hello. If it's false, it will display hello world. So let's run it as is the first time. So right now it's going to display by. It displays by because 6 is not equal to 5. Okay, let's make it so it displays true in the first if statement. So now this will be true. Now 5 equals 5, and then it will come into here. So let's see what happens now. If we run it, it says hello. It says hello because when it comes into the this if part, it says if my bool equals true. Well, my bool is true, so then it will display the hello. But then if we make it false, my bool is false now, and run it, now it displays hello world. So it says 5 equals 5, check, comes into here. My bool equals true, well that's false because my bool is false. Then it comes to that else, and then displays the hello world there. So that's the basics with if-else statements nested. But now that we know this information, we can kind of rebuild the program that we made before, but now we'll use if-else statements. So now let's do it again. So first, let's make our constraints or our constant variables. But this time we don't need a low one because we have the else. So we'll say if it's greater than high, do something, else do something else. So we don't need to compare it with the low anymore. So we'll start off with saying const int high equals 10. Then we'll say console.writeLine, enter a number, same thing before. Then we'll say int number that's entered equals int.parse console.readLine. So we're saying whatever number they entered in, take that, convert it to an integer, and store it into my number. Now we can start doing our checks. We'll say if number is greater than high, then we'll display to the console the number entered is greater than our highest. So we'll say we'll place in our first placeholder the number that was entered, and then our second one will be high, which is our highest number. So that's our first else. Now, our first if, and then we'll add an else statement saying if number is not greater than high, then this will happen, and we'll display another message here. We'll say we'll just add a not is not. So we'll say the number entered is not greater than the highest number. So let's run the program now. It says enter a number. We'll put in, let's first do a 15. And then it says 15 is greater than 10. So it came into here because 15 is greater than 10. Let's do now a 9. Now it says 9 is not greater than 10. And that's because 9 was placed into here, and is 9 greater than 10? No, it's not. So it goes to the else part or the false part, and then it will execute this line of code. So that's our old program, but now we use if-else statements to make it a little bit more robust. Alright, so now that we understand if-else statements and nested if statements, let's talk about compound expressions in an if statement. So up to this point, we've been just in our if statements, we've been just checking one expression pretty much. We've been saying, okay, if number is greater than high, or if something equals true, or we're only checking one thing. But there's ways that we can check multiple things in different contexts. We can check multiple things by using an AND statement, by saying if something is let's say we can say if something is true and something else is true, or we could say if something is true or something else is true. So I'll explain them both, the conditional AND and the conditional OR operators right now. So let's say we want to, actually before I make a program, let's just go over how they work. So let's create a couple of variables. Let's say int x equals 5, int y equals 10. So let's say we want to do an if statement saying if x is 5 and y is 10, meaning that they both have to be true. We would in this case use an end statement. So we would say if x equals 5 and, which is two ampersands, and that's an end statement. So we're saying if x equals 5 and y equals 10, then we'll do something in here. Now, with an end statement, both, or how many expressions you have, all have to be true in order for the if statement to evaluate to true. So let's say I'm going to put it in a message console write line true. So in order for this to work, x has to be 5 and y has to be 10. If one of these are false, then this won't happen. So for instance, let's run it. We'll see that it does say true because they both are true. This portion is true and that portion is true. But if I change, let's say I change y to 11 instead, so now this portion of the if statement is false because 11 is not equal to 10. So if I run the program now it won't display anything because in order for an end statement or an end compound expression to evaluate to true, these both have to evaluate to true. And since they both don't, it won't execute this line of code. However, because although this evaluates to true, I could put in an else statement and then display console false. And now if I ran it, it would say false. Oops, sorry about that. Now if I ran it, it would display false because this evaluated, the first if statement evaluated to false because this portion of it is false, and in order for an end statement to be true, they both have to be true. So I'll just make this a 10 again and run it, and now we'll see that it says true because they're both sides of the end are true. Now, however, there's an OR statement. An OR statement looks like this. Hold on. It's two up straight lines. I don't know what they're called. It's below the delete key, and you hit this shift. So it's shift, whatever is below the backslash. So it's shift backslash, and that's an OR statement. So we're saying if x is 5 or y is 10. Now with an OR statement, only one of them has to be true for the whole thing to be true. So right here, if I ran it, it would still stay true because they're both true. However, if I made y 11, it would still stay true because at least one of them are true. So because x is 5, this will still evaluate to true because at least one is true. In order for an OR statement to evaluate to false, which is in here, both of them have to be false. So if I made 6, x6 now it would be false because both sides of the OR statement evaluated to false. Yeah, so that's the basic idea behind an AND and an OR. I can do more. I can stack these up and say more ANDs. I could be like x equals 5, y equals 10, and something else, and something else, and something else, and go on. But the general idea that an AND statement is true when all are true, and an OR statement is true when at least one is true. So that's the difference between an AND and an OR. So now that we know this, we can build a simple program. So let's say we wanted to build a program that asks the user to enter in their age and their name. And let's say we wanted to first do an end comparison. We wanted to say if their age is greater than 10 and less than 50,
then they're approved to do something. So let's do that. So let's say to the user, console.writeLine, enter your age. We'll then display their age into an integer. So we'll say int age equals int.parse console.readLine. So now we have their age. Now we'll say enter in your name, and then we'll say a name is going to be a string, so we'll say string name. And notice now we don't have to parse it because console.readLine automatically comes in as a string, so we don't have to parse it. So now we have their age and their name stored into two variables. Now we can do some checks. The first check what we want to do is that the first check we don't need their name, but we're still going to store it anyway. The first check we're just going to check if their age is in between our requirements, which is 15 and 50. So we're going to say if age is greater than 10, so they're at least 10 years old, and their age is less than 50. So by this statement, now we know if this evaluates to true, our person is at least 10 years old, but he is not greater than 50. If either of these are false, this will not get executed. So let's write console dot write line approved. So if we run the program now, if we enter in our age, let's say we're 15, and our name will say Bob, doesn't really matter right now, but you notice that we are approved because 15 satisfies both sides of this equation. 15 is greater than 10 and is less than 50. If I changed it to, let's say 9, and Bob again, it does not say approved. Actually, let's add in an else, just so we can see it. And let's say denied. And then run the program again. Let's enter in a 9 now, and then a Bob. Now we're denied because 9 dissatisfies this side of the equation, but although it still satisfies this side of the equation because 9 is less than 50, but since it's not greater than 10, they're denied access to whatever we're doing. That's and then I actually let me do one that's greater. So let's do one that's 55, and then Bob. Notice how we're also denied here because 55 is greater than 50, and that makes our expression false. And with an n, they both have to be true. However, let's change this up to use an or statement. Let's make an exception. Let's say if they're greater than 10 or their name equals Bob. So now this makes it a little bit more complicated. If they're 10, they'll be approved. If they're less than 10, they'll be denied. However, there's an exception because we have an or. So we're saying or if their name is Bob. So if their name is Bob, they'll still be approved. So let's first say, okay, name. Let's say we're 15. No, let's say we're 9, and our name is Henry. We're denied because our age is or we're denied because both of them are true. I mean, both of them are false. Our age is less than 10, so that the first part of our or statement is false. And then our second part, or our name is Bob. Well, our name is Henry, so that's false also, so we're denied. However, let's say we are 9 years old, but our name is Bob. Now we are approved because in or statement, only one of the expressions have to be true. Since our age is false, okay, that first part is false, but because our second part of our if statement is true, which is our name equals Bob, that's true because our name was Bob, we are still approved because at least one side of the or statement is true. So that's the basics with using compound express
compound expression in if statements. Okay, so now that we got through that, let's build upon using our if-else statements. I want to show how they're connected to what switch statements are, which I'll get to. So let's make a program that asks the user. Let's make a program that asks the user to enter in a year of what grade they are in high school. So for instance, if they entered in a 1, that means they are a freshman, a 2 is a sophomore, a 3 is a junior, and a 4 is a senior. So and if they don't enter in a 1, 2, 3, or 4, then it's an invalid year. So to start this off, we need to ask the user to enter a year. So let's say console.writeLine enter a year. Then we'll take in that year. It's an integer, so we'll say entered year is equal to int.parse console.readLine. So now we have their year that they entered stored into our entered year variable, and now we're gonna start doing stuff. So if they enter a 1, we want to display that they're a freshman, and so on. So we'll use if statements, because that's all we know how to do right now. So we'll say if entered year equals 1, console.writeLine freshman. Okay, so that's our if with our freshman. So now if they enter in a 1, we'll display freshman. Now we'll do an else if. Actually, I forgot. I didn't even explain this yet. Okay. Um, so along with the if-else statements, in order for us to do this program, since we have multiple checks, so if they enter in a 1, we'll display freshman. If they enter in a 2, we'll have to display something else. If they enter in a 3, we'll have to display something else. Since we have that kind of pattern, we can't just do if-else statements, because if-else statements would only work with only one check. We have to check if enter number equals 1, else would mean if anything else was typed in. Because we have to do more checks, we have to do what are called if-else statements. Else if statements. Sorry. Else if statements say that if the first if is not true, it goes to the else. But then it does another check. Now we can say else if for another check entered number equals 2. So if that's true, then we'll display another message. We'll display sophomore. Then we could do another else if. We'll say another else if entered year equals 3. So by doing this else if pattern, we're doing a chain. We're saying if this is true, do that. If it's not true, go to the next one. And then it evaluates this. If this is true, it will do this. If that's not true, then it will go to the next one. And we can keep on doing comparisons. So if this one's not true, it will go. This is still considered the false section of this if statement. But in the false section, we're doing another comparison. So we're saying else if. So else if this is true, then we'll do this. Else if this is true, then we'll do whatever's in here. So we'll display junior. And then else if entered year equals 4, then we'll say senior. Now we have our chain. We have our chain set up that will display, if when they type in a year, it will display what they're a freshman, sophomore, junior, or senior. So we run the program. We type in a 3, you'll see that it says I'm a junior, which is correct. However, what if they type in a 5? We didn't program anything. Now it doesn't say anything.
And that's where our else portion comes into play. Now we just say else, and we say console.writeLine, invalid year. The else portion says if none of these are true, then do this, which is what we're used to. If none of these are evaluated to true, we'll do the else. So the else if is kind of like a chain series. We kind of connected these all into a chain, and then this else statement kind of applies to the entire chain. If none of these are true, it will do the else statement. So now if I run it and type in a 5, now it will say invalid year. Now this chain of if else is bring me to what are called switch statements, which were kind of designed to or kind of can replace this if else chain series into a more easy readable way, and I'll explain if switch statements here now. Okay, so like I said, the switch statement can replace the if else is if the else if chain series. So to see what it looks like, I'll remake this program using the switch statement. So we'll keep that. So the syntax for a switch statement is first the switch keyword. Now the switch statement is very similar to the if else chain series in a couple of ways. The first thing what the switch statement does is we switch an expression. We're saying switch something. And then by saying switch something, we can list the possible outcomes of what that something can be. So let's say if we switch entered gears, now we make our blocks for our switch statement, and now we can add our possibilities of what entered years can be. So each possibility gets what it's called its own case. A case you can think of a case as a possibility. So an entered year can have a possibility of being a 1, which is a freshman, a 2, which is a sophomore, and so on. So we list those possibilities as cases. So case 1 is our first possibility. And then we put our colon. That's just syntax. Then we put our blocks for that case. So now in our case 1, we can say console.writeLine freshman. So that's so almost the completion of a case. So we're saying switch entered number and one possibility of entered number. So switch is kind of saying list all the possibilities of what entered number can be. So we're saying one possibility is a 1. So we're saying if it is a 1, display console.writeLine freshman. Now the last thing in our case, we need to put in a break. The break statement kind of just says stop here. It says don't go to the next case statement. It's kind of just a terminator for a case because we'll have multiple cases. So if I add another case or case 2, because that's another possibility it can be, and then console.writeLine and put sophomore, by putting in these breaks, it's saying don't if we do case 1, the break saying don't go to case 2. It kind of says stop here at case 1. It says stop here in case 1 and then break out of the switch statement. By saying break out, so once it does case 1, it hits break, it will jump out of the switch statement and then start doing the code that is down here. Whatever code is after the switch statement, it will continue where it left off. So the break statement just says break out of the switch statement and continue what you were doing. Yeah, so that's the break statement. So let's continue to keep on listing the possibilities. So case 3, console.writeLine. Alright, so that's our switch statement. It's now complete. If I would run the program and do the same thing, hit enter a 3, it still says junior. So that's how it works the same way as the if-else series. But now, if you remember from the if-else series, if the user entered in an invalid year, it would display invalid year. Now, we can do the same thing with the switch statement, and that's a special kind of case. It's called the default case. So if I put it in a default case here and do a console.writeLine invalid year and then a break, now we have our default case. Our default case says that if the if what we're switching, if all the possibilities that we listed, if whatever they typed in is not one of these possibilities or not one of these cases, it will do the default case. So if I type in a 5 now, it says invalid year because we didn't list a case for 5. So yeah, that's the default case in our switch statement. So that's the basics of if statements, if else statements, nested if statements, if else chain series, and then switch statements. So these are a bunch of tools that allow you to do different actions based off of different things, different expressions, different things that you're testing, and things like that. Um, So yeah, like I said, the switch statement replaces the if-else chain series, but you could use the if-else statement if you wanted to and do that whole chain, but it's just considered a better programming practice to use the switch statement in circumstances like this because it's easier to read and things like that. However, if you were doing an if-else chain series that was comparing things for greater than and less than, so if you were checking if things were greater than something and less than something, you couldn't do a switch statement because in C Sharp, other languages do support it like Visual Basic, but in C Sharp you can't do a case that checks ranges. So I couldn't say like if case entered year is greater than 50. I couldn't do that. With switch statements in C Sharp, I can only check for things that are equal. So I only can say if entered number is 1. I can't say if entered number is greater than 1. So in that case, I would have to do an if-else series. Now there's one more thing with the switching that I want to show you. Let's say I wanted to merge 3 and 4, year 3 and 4 together into an upper class case. I could do that by simply adding, by taking out the case declaration here. So if I just put in case 3 colon with no break, with nothing else, followed by case 4, now if they entered in a case 3, or if they entered in a 3 or 4, it would do whatever is in the 4. So this kind of falls through. The 3 kind of falls through because I don't have a break. So now I can change this to like upper class. And now if I run the program and enter in a 3, it will display upper class because 3 is now a 4. If it enters a 3, it will do whatever the 4 is. And if I entered a 4, it will also still say upper class. So now 3 and 4 are both considered upper class. And this is like kind of the concept of using multiple labels without break statements. So that's that. Now let's finish off this lesson by doing a simple challenge. And our challenge for today will be this. So our challenge is to write a console-based program for a lawn mowing service. The lawn mowing season lasts 20 weeks. The weekly fee for mowing a lot under 400 square feet is $25. The fee for a lot that is 400 square feet or more, but under 600 square feet, is $35 per week. The fee for a lot that is 600 square feet or over is $50 per week. So we have to prompt the user for the length and the width the length and the width of a lawn, and then display the weekly mowing fee as well as the total fee for the 20-week season. Now, if you want to try this by yourself, everything that you learn this lesson, you have all the tools to build this program. So if you want to take a challenge and do it yourself, pause the video here and try it yourself. If not, you can watch it and I'll solve it here for everyone else who just wants to see how you would build a program like this. Alright, so let's just do this. So let's delete what we have. Alright, let's get started. So the first thing that we have to do is prompt the users to enter in our length of our lawn and the width of the lawn. So let's do that. We'll say console.writeLine, enter length of the lawn, and now we gotta store that somewhere. So we'll store that into a double. A double is something they could hold a decimal because they could, I guess, put in a decimal a decimal value. So we'll say double length equals double dot parse console.readline. Now we could also do this with integers if we wanted to, but that would just, if they were to enter in a decimal value, a decimal value, it would crash our program because, like I said, we can't enter in a double value. We can't store a double into an integer unless we did some casting. But anyway, so yeah, so enter length of the lawn, and now we'll say console.writeLine, console.writeLine, enter width of the lawn, and then we'll say double width equals double dot parse console.readline. So now we have both our length and width stored into memory after they typed it in. Now we need to take our length and width and convert it into square feet because that's what the program wants. So by doing that, we'll just do double square feet equals length times width. So now we took our length and width, we multiplied them and stored them into a variable called square feet. Now that we have our square feet variable that holds our data, now we can start doing the checks. But when we do the checks, we need to store the. So if you look at the program, it says, for instance, so if the weekly fee for mowing a lot under 400, so if the square feet is less than 400, our fee is 25. So we need to store that $25 into a variable. So in lesson 1, if I make a variable called weekly price and put a semicolon, by doing this, I'm not assigning a value to this variable yet. I'm going to assign the price of this variable once I determine in my if statements what the price is going to be. So the first if statement I'm going to use is if square feet is less than 400, then my weekly price is 25, is what the program says. So here I assigned the first price of it, not here. But I can't use weekly price, like I couldn't display weekly price until, or use this in like math or something until I assigned it, which I did here. Now, so that's our first if. The next one, what the program says for us to do is to do if the square feet is greater than or equal to 400 and less than 600. So if we read the program, it says the fee for a lot that is 400 or more, so that's greater than and less than because it includes 400, but under 600, so that's just less than. That does not include 600. So that would be $35 per week. So we'll use an if else. So we'll say else if square feet is greater than or equal to 400, and we use a compound here because we need to make sure it's less than 600 also, and square feet is less than 600. It's not less than or equal to because we do not want to include 600, because if it's 600 it's a different price. So then for this, our weekly price will be $35. And then if we go back, our last one is if the fee of the lot that is 600 square feet or over. So this is anything else. 600 feet or over is $50 per week. So there's two ways I could do this. I could go like this and say if else square feet is greater than or equal to 600, and then do weekly price equals 50. That would work. However, I don't have to do this because since we checked for everything else already, we checked that if it's less than 400, we checked that if it's greater than or equal to 400 and less than 600. So we checked everything that is less than 600. We don't have to say if it's greater than or equal to 600 because greater than or equal to 600 is everything else. So I could essentially just delete this and just say else. I could say else weekly price is equal to 50 because else includes everything else that is not this, which is only things that are greater than or equal to 600 because things that are less than 600 are in this else if, and everything else would be in this else statement. So everything else is here. So now we have all our prices set in stone. So now we know our price for all our square feet. Now we just have to simply display them to the console. So the first thing it says display, it says display the price of the weekly mowing fee and the total fee for the 20-week season. So the first thing I will do is console.writeLine weekly mowing fee is $. We'll use a placeholder, and then we'll fill in our placeholder with the weekly price. Oops. Console.writeLine. So we'll fill in our price in our placeholders with our weekly price, which we set depending on our if statement. And then we'll do the total monthly for the season, which is going to be console.writeLine. Come on. Console.writeLine total mowing fee for 20-week season is $ placeholder, and then what we're going to put into our placeholder is our weekly price. But since we want it for the season is 20 weeks long, so we'll do that and times that by 20, and that will be our our 20-week season price. Now, instead of doing this weekly price times 20 here, we could do this. This will work fine. Instead, we could have also just stored this into a variable. We could have said double season price is equal to weekly price times 20, and then just put that season price into this placeholder instead of doing the multiplication there in text. So I could have done an in-text multiplication, or I could make a variable like that. Whatever one is more easy for you to read. It doesn't really matter. It's generally a good practice to do it with the variable, but because for instance, if we wanted to display the season price again somewhere else, if we did it in text like this, and we wanted to, let's say, change it to a 21-week season, we would have to change it in multiple places, that 21. Whereas if we put it into a variable, we'd only have to change it once, and then that would get fixed wherever we would display the season price. But once we get into more object-oriented concepts and stuff like that, I'll explain more ideas with that eventually, but that's just a little bit into that. So it's a good idea to generally make variables like this. So this is our program. If we run the program, we can see enter a length. I'll do a 10 by 50. I'll do yeah, I'll do 10 by 50 yard. You can see that fits into, that's going to be a 500 square feet yard, which fits into the else if here because 500 is greater than or equal to 400 and it's less than 600. So our price would be $35 as you can see. And then as you can see our weekly mowing fee is $35 and then our total mowing fee for the 20-week season is $700, which is correct. So if I were to run this again, let's say, I don't know, a 5 by 25 yard. Now you'll see that our price is $25 because it is less than 400. Our square feet, 5 times 25 is less than 400. And then our price for the 20-week season would be $500. So that is the completed program or the challenge for this lesson. Yeah, so this is the working program. So we're starting to move towards a little bit more complex programs. We're getting a little bit more in length. Our last program for last lesson was building a simple calculator, which was just adding. So now we're doing more. We're doing some multiplication. Now we're doing if statements. We're making decisions based off of different things happening. And then we're displaying stuff to the console. So we're starting to get a little bit more advanced, which is good. So we're starting to get there. So this is our second lesson, and I hope everyone enjoyed it, and thank you for watching.